Okay, this is a very, I don't want to say like, no, I don't want to say a hard lesson. It's factoring. All right, I'll tell you that right now. It's factoring. Okay, and it's got two different types. One type is much similar to when we factor stuff like this, x squared minus 49. Okay, anybody know how that factors off top? X plus 7, x minus 7, called a what? What's the special name to it? Nah, that's trinomials. This one is a...
Complex conjugate?
No. Now you're just spewing crap.
Yeah, I know.
Difference of squares. Difference of squares. Okay? Okay, difference of squares. All right. Now, there is no such thing as sum of squares. Remember that? Okay, we had mentioned that before. There's no such thing as sum of squares. We are now moving into cubes. All right? And factoring sum and difference of cubes. All right? And the way you do so is what is over here underneath the general case. A cubed plus b cubed, a cubed minus b cubed. All right? Very similar to how you do difference of squares. Okay, so I'm going to write up here on top in red, difference of squares. And the general case for that is if you're given a squared minus b squared, it factors a plus b, a minus b. That's how it factors, general case. Okay? Your sum and difference of two cubes factor similarly, still slightly different. Okay? But that's the same kind of setup. You're going to be given two terms. Okay? Two terms, that's the key. All right, two terms. One will be something being cubed, then a sign in the middle, plus or minus, because there's both in play now. And then there's something else that's being cubed.
Will they both always be cubed?
Yes, or you'll be able to factor something out, or you'll not be able to do it at all.
So it's never going to be square.
No, this will always be something that you can either. So make sure somewhere along the line you write this down. Okay, that's how these factor. That tells you straight how they factor. All right. So for sum of two cubes, yes, you need to memorize those. By the way, okay. If you're given something being cubed plus something else being cubed, the easiest way to do it is look at the similarities. All right, between the two. They're both a binomial times a trinomial. Everybody see that? Okay, they're both a binomial times a trinomial. What else is similar about them? What do you notice? What's the exact same in both? Everything besides the signs. Okay, so what I call your letter sequence in both is the exact same. Okay, it goes A, B, A squared, AB, B squared. A, B, A squared, AB, B squared. What does AB mean? What's AB? It's two things being multiplied together, A times B. All right? Obviously, A squared is A being squared, B squared is B being squared. A and B are whatever the initial small parts are. The only tricky part to remember, honestly, are the signs. Okay? And they're not even too bad. Whatever sign you're given is what sign goes in the binomial. Okay? So if I give you plus, you put plus. If I give you minus, you put minus. The first sign, the trinomial, is the opposite of what's ahead of it. So if this is a plus, then this is a minus. If this is a minus, then this is a plus. The last sign, always plus. Always. Okay? To be honest, this is probably your most complicated factoring technique. Okay, this is I think at least this is harder than what we're going to do after a while, hopefully. Okay. Now, it is at this point that the book starts throwing in some primes to you also. Okay, stuff that cannot be factored. prime polynomials, so you may not be driving yourself nuts if you can't factor something. All right, that can happen from time to time. Your bookwork that you're going to have on Monday will have a few like that. Maybe I'll occasionally sneak one into a quiz just to mess with you a little bit. It won't be like all of them. Okay, don't go through that factoring and just write down all prime.
Or maybe you should.
All right, maybe I should really mess with you. Whew. Mr. Jenkins.
Will there be like key indications, or will like we have to?
That's actually a good question. It'll say factor, and you have to know how to do it. Okay, that's all it'll say is factor. All right. Everybody, good.
So like when we think we're doing it wrong, it may not actually be doing it wrong.
You're right. You may not. Okay. Okay, we're going to start with basics examples. A couple of them. All right. So factor each if the polynomial cannot be factored right prime. Okay. So, you have to ask yourself, what I do first each time is I figure out my binomial. Okay? I figure out my binomial. And since this is a plus here, a plus is going to go there. Okay? For this to work, this first term has to be something that's being cubed. The second term has to be something that's being cubed. So what's being cubed on the first term here? X. Right? X is being cubed. Okay. What's being cubed in the second term? 4. Okay, 4 times 4 times 4 gives you 64. 4. Okay. Once you have that, then X is your A, 4 is your B. All right? From there, you can fill in your trinomial. Okay, and that's understanding and knowing the letter pattern. The first term of the trinomial is A squared. So A is what? X. Square it. It's what? X squared. Since the first sign is plus, the second sign here is? Opposite. Minus. Okay, you're making a trinomial, so you're going to have 2 more signs. All right. Okay. Now, the next one is A times B. So what's X times 4? 4X. All right, so say it, the way you should write it. The next sign is always what? Plus. Every single time that sign is plus. And then now square B. So 4 squared is? 16. There you go.
So that's all we have to do.
That's your answer.
So there's not much work that goes into it?
There's not much work to show at all.
Okay.
Nope. There isn't really, and even later, there's only going to be like 2 lines. Okay? It's do you understand how to do it? There's not much work to show at all. Okay? All right, so keeping it, Kendall?
Okay, so you chose the sum of 2 cubes for that equation because it's addition in this problem, but if it's subtraction, that's going to be the difference.
Then you're going to do the difference, correct. Okay, DeMarcus?
Is there a way like that we can know the cube, like the cubes, like?
Yeah, I'll show you in a little bit. All right, I'll show you that in a little bit. But I'll tell you this. I won't go bigger than 216. Okay? I won't go bigger than 216. Okay? And 216 is 6. Okay? After that, as you get practice, you'll know them. Okay? So, now the next one, y cubed minus 216. So, a binomial, a trinomial. Okay? So, what's being cubed first? Y. All right. Next, the sign I gave you is a minus. What's being cubed there? 6. All right. Now, y acts as your A, 6 acts as your B. All right. So now a squared would give you y squared. What's the next sign? Plus. Okay. Even though, this is where this one's weird. Even though you've been trained to think that this is A and this is B and this is negative 6, the next sign takes precedence as plus. Okay. plus a times b is 6y, plus, what's 6 times 6? 36. Okay? Remember what these need to FOIL back to. Okay? Or distribute back to. The originals. Okay? The originals. Okay? 125x cubed minus 8. Okay? First one's a difference, so same way. Binomial, trinomial. Okay, now, this would be just x cubed minus 8. Okay? And if it was just x cubed, then you would say the thing that's being cubed is what? X. Okay? But it's 125x cubed. So it has a number attached to it, so right here you're going to have a number attached to your x also, and that number is going to be what? 5. So for 125x cubed, you put 5x. Minus 2. Okay? Now, pay attention to what your a is then. A is 5x. So you have to do 5x squared. So 5x times 5x gives you what? 25x squared. That's a beautiful x. Let's try that again. There we go. Okay, that's a squared. Next sign is what? Plus. What's a times b? Should be 10x. 5x times 2, okay? 5x times 2, 10x. Plus b squared, 4. All right. Okay.
Yeah, why wouldn't it be negative?
Because it's signed in between. If this is a minus,
Yeah.
this sign's the opposite.
Oh, so even if it would
Yep.
it's still gonna-
Yep. No matter what. Okay. Otherwise it doesn't FOIL back to this. Or multiply back to that, okay? Okay. The sign pattern is what makes it multiply back to the original. So that's why it takes precedence over what you would think, okay? All right, so 27y cubed plus 64. 27y cubed would become what? 3y, okay? I think you've pretty much seen all of my cards for this now, as far as the numbers themselves go. All right, 1, yeah, 8, yeah. 27, 64, 125, 216, yeah, you've seen them all now, okay? Plus 64 becomes 4, all right? Then what? Then 9y squared. Be careful. Minus hurts and pluses in there. Multiply them, so 12y plus 4. Okay. Remember from the first slide, those sign patterns that are in the general case. Oh, 16, my fault. Sorry. Hey, for how it was going earlier, for that to be my first mistake, that ain't bad. Okay. The sign patterns that are in your general case are what takes precedence. All right. You don't worry about how a and b are both positive here, and when you do 3y times 4, it gives you 12. This sign is a negative, no matter what. If this is a plus. Okay. Mr. Jenkins. Okay. Everybody good? Marcus? These two, not prime. I'll tell you that right now. All right. So, number 1, 2x cubed plus 432. Ooh. Everybody's favorite factoring technique. Everybody forgets about is what? No. Factoring technique.
Oh.
That's all. Factoring technique that everybody forgets about.
The one over your mouth?
Yes, that one is what? Nope. The factoring technique. Listen. The factoring technique that everybody forgets is GCF. Greatest common factor. You have to look for that. Okay? Looking for that. 2x cubed plus 432. What can you take out of both of those? 2. A 2. Okay? Hopefully it's pretty obvious because they're both even. Alright? Alright. So you take out a 2 first, which leaves you with x cubed plus
216.
216. Okay? Now, look at what you can keep doing now. We've done this one already. Or one, at least we've done x cubed and 216. Maybe not the sum, but the difference. Okay? So now you can go again. All right? Now you apply the sum of 2 cubes rule on just this. What happens to this 2?
It stays in front of that parentheses.
It hangs out. It stays there. All right? So 2 parentheses your binomial, parentheses your trinomial. The first thing being cubed is what? X, and then 6. Okay, just remember, inside here just applies to here. Okay, the 2's out here, it already takes care of this part, the 2's being up there. Extra, please. This 2 just chills. So you just square this, you multiply them. All right, so x times x, x squared. Next sign is minus 6 times x, 6x. Next sign is plus 6 times 6. And you're done. That's it. Okay? Harrison.
If we can do like, or we can just like get rid of the x squared do that, but then we still want to put x squared plus 2.
What do you mean?
Like if it's like that, and we can just like mentally get x plus 6 or something, or like I guess if we can mentally
So basically what you're saying is if you can go from here down to here,
yeah, you still want us to have the first.
I want you to show me this line. This isn't much. Show me this. My concern is you messing this line up by going from here to here. This would be a good safety net to prevent that from happening. Show me this line. Okay? All right. So the last one up here, 375x cubed minus 81y cubed. Also not prime. It is 3. Okay? Because 375 divided by 3 gives you what? 125. All right? Hopefully most times one of them, this is going to sound, I don't want this to sound arrogant, but it probably will. One of them should be somewhat obvious as what you need to factor out, okay? For example, up here on the 2, x cubed, hopefully you know to factor out a 2 first. Okay, or at least see, now that you know how to do these, see that you should factor out a 2 first, and see what this gives you. 120. Once you guys get used to this, 125 is going to become pretty commonplace. So seeing that 125 is, a couple factors off from 375, that should be your cue for that one. Okay? And then work the other one. So negative 81, if you're going to factor out that 3, is going to become what? What's that something? 27. Y cubed. Okay. Okay, that last one's got a few more terms attached to it, but if it changes your problem none, you still go and work it through. Okay, so 3 parentheses. What's being cubed here? 5x. Okay, 5x. Next sign is minus. What's being cubed here? 3y. Okay. Now, 5x becomes your A, 3y becomes your B. Okay, so 5x times 5x. 25x squared. What's the next sign? Plus. Okay, remember it's the opposite of what's in the binomial. Comes second. 5x times 3y. 15xy. Good. Okay, going above the logo, hopefully. All right, what sign is next? Plus. It's 3y times 3y. 9y squared. Done. Okay. It's not prime. Okay?
All the signs are cursed.
Yeah, I know. Okay? Not prime. How many terms? 4. Okay? And up to now, up to this point in your life, January 20th, 1248, you've only factored with the max of 3 terms unless it's been a general GCF throughout. That's what you've done. We're going to switch. Okay? This technique is what we call grouping. Okay? Grouping. Instead of going through the general case of grouping, I'm going to kind of explain it to you with the first example, all right? Can anybody just take a guess, using some context of the problem? To factor by grouping, what do you think we're going to do?
Take everything that can be.
Now, simpler than that. Mr. Jenkins.
Find the least common factor.
Not quite. But if we're going to do something by grouping, we're going to probably, Roach,
Numbers together that can be
Make-
by terms.
make groups.
Well, yeah. Makes sense.
Mathematicians are lazy people. We name things for the obvious. You factor by grouping. How? You make groups. We're not creative people. That's for the other side of brain people. That ain't us. Okay? We're going to group. What we're going to group? We're going to group this together and this together. Okay? Always in 2. Okay? You will always be able to get through with it being split in 2. As you get better, those groups will not always necessarily be next to each other.
Okay, that's what I was looking at.
Starting off, they will, though. Okay? Starting off, they will be right next to each other. Shh. Okay? Everybody good? Now, what's the most forgotten technique of factoring? GCF. The reason why I've said that twice now, because it comes back with a blaze of glory today. All right? Because your next job is to do this. You need to take this first group, 20x cubed minus 25x squared. And you need to take the GCF out of it. So the biggest number that goes into 20 and 25 is what? 5. Okay?
I'm taking x squared out.
And you take what else out?
X squared.
X squared. Okay?
So it's going to give you the exact same thing.
Which is, hang tight. Which is going to leave you with what?
4x minus 5.
Minus 5. Okay? 5x squared, parentheses, 4x minus 5. Okay? DeMarcus.
Okay. Where do you take it? Why do you take 5x squared?
I took them out of here. See, 20 divided by 5, or 20 divided by 5 gives you 4. 25 divided by 5 gives you 5. X cubed divided by x squared gives you x. X squared divided by x squared gives you no x's. Okay? So that's the first group with the GCF factoring. Everybody see that? Okay? Now, your next part. This is where you have to change your mindset. Now, obviously, for this one, hopefully it makes a little more sense because it is the first one you've ever seen. You're going to set up the second one, the second group, the same way. Except your rule changes. You have to factor something out so that your binomial here is the same as here. So we need our binomial to be 4x minus 5. Okay? You have to do this. You have to factor something out of both groups. Because our answer, whenever we have 4 terms, is going to become 2 binomials. Everybody with me on the terms? Okay? That's why we do vocab quizzes. When I say this mathematical stuff, you know what I mean. Okay? Everybody good? Now, what are we going to factor out of 4x minus 5 to keep it as 4x minus 5?
1.
1. So you put a 1, and you do put that 1.
Okay. Yeah.
Okay? Yes. Because remember what I said we're going to turn this into? 2 binomials. Okay? Everybody good so far? All right, now, from here, think about this a little bit out of the box. A little out of the box thinking here. How many terms are up there, do you see? How many? Okay. Think out of the box.
4.
What do you mean box?
Okay. Individually speaking, in what you have thought to be terms for your whole life, I see 6. 5x squared, 4x, negative 5. 1, 4x, negative 5.
Okay.
I see 6, as you've been taught.
There's 3.
I'm going to tell you this. There's 2.
Oh, wait, what?
There's 2. There's 2.
Minus
Oh, yeah.
5.
Okay?
Yes.
Remember what we're doing here. It's called grouping.
5x
Okay.
squared plus 1.
This is, consider this, now listen, okay, pay attention here. Consider this as one term. Consider this as one term. And I ask you this. What's the GCF out of those 2 terms? What do they have in common? Roach. 4x minus 5. Right there. Right there. So factor one of them out. Since you have common terms, or common terms in 2 common in 2 terms, there we go. You can factor it out, just like we did up here, right? There's a 5x squared common in these 2, we factored it out. There was 1 common in these 2, we factored it out. Down here, there's a 4x minus 5 common in them, we factored it out. Which leaves you with what? 5x squared plus 1, since this is a plus right here. And what did I say we're going to turn these into? 2 binomials. What do we have? Done. GCF out of the first group. X squared. Okay. So x squared, you're left with x minus 3. Okay. Now, here's where you do that. All right. Now your hand is forced. This next binomial has to be x minus 3. Otherwise, this whole thing does not work. Okay. That has to be x minus 3. So, I'm going to grab that parenthesis up top with me. I didn't realize that, but that's okay. All right, so what do you have to factor out of the second group to make that be an x minus 3 tenuous? Negative 5.
3.
Okay? A negative 5. Factor negative 5 out, not a positive. If you do factor a positive out, you'll just be signs off. The way you fix that, factor out a negative. Okay? Everybody see that trick? What are you left with then? You got an x minus 3 common, leaving you with x squared minus 5.